Hi everyone, welcome back to another day of notes. Um, okay, what am I trying to click? I'm trying to make a big screen, sorry. And now I need to get rid of this so you can see everything. So last time we talked about graphing systems, and that was one of the three methods that you could do to solve a system of equations. The second method we're going to do is substitution. Okay, so we're going to focus on substitution today, and it seems like a lot of steps. It's really not. Okay? I just had to write it out as a few steps. So step one is to isolate a variable. It doesn't really matter which variable you isolate. Most likely there's going to be one that's really nice and easy to isolate. Probably has no coefficient, which is really nice. But it doesn't really matter. So you just pick a variable and isolate it. Then you're going to substitute the expression that the variable is equal to into the other equation. This all sounds very complicated, and it wording wise it kind of is. Once we do it, it'll make so much sense. Okay? Once we've substituted in that expression, we should only have one variable left in that equation, and we can solve for the remaining variable. Okay? And then once we have one of our variables, either an x or a y, we can use that to plug into one of the original equations. And again, we only have one variable left, and we solve for the second variable. And then once we have our two, we write our solution. I know, it sounds awful, okay? It's actually quite easy, all right? So let's try an example instead. We're going to do this by substitution, okay? Now, SOL, some of your tests on this, you'll be able to pick your own method. So if you'd prefer to do graphing, you can. There will be some questions that require you to do it a certain way though, okay? Specifically on your quiz. So you need to be equipped for all three, but if you prefer one over the other, you can go ahead and go with your preferred method, okay? So, substitution though, we are going to isolate a variable. Now this equation already has a variable by itself, so we're going to use that one. It's already isolated. Step one, done. Okay? The next thing we need to do is take what it equals, the 5 minus 2y, and we are going to plug that in for the x in this equation. So right there, we're going to plug it in. Okay? And whenever we plug something in, we're going to use our parentheses. So now I have, for this top equation, 3 times that expression, 5 minus 2y, minus y, just the rest of the equation. And this was also supposed to be a 1. My bad. Change that to a 1. Change it to a 1. Okay? Equals 1. Now, if you notice, there's only y's here, which is what we want. We really only want one variable. So, now that there's only one variable, I can go ahead and solve. So first I'm going to go ahead and distribute the 3. So I get 15 minus 6y minus y equals 1. Now I can combine my like terms of my y's. So negative 6 and negative 1. That will give me negative 7y, and I just bring everything down. Now it's just a two-step, and I go ahead and solve. So I subtract 15 from both sides, and I'm left with negative 7y equals negative 14. So then I go ahead and divide everything by negative 7. I get y equals 2. That's 1/2 of my solution. One part of it is already done. Y equals 2. Okay? Now that I know what y equals, I can take that and substitute it into the original equation and for the y in the problem. So I'm going to plug it into the bottom one. It doesn't really matter which one you plug it into, but the bottom one's just a little bit easier, I think. So I'm going to plug it into the bottom one, where x equals 5 minus 2 times y, but instead of y, I'm going to put 2. Okay? So, and by the way, if you're listening to this, you're also doing it at home, so you should be listening to it anyway. Never mind. 2, I'm going to go ahead and multiply. 2 times 2, and that gives me 4, and then I just go ahead and simplify. 5 minus 4, I get x equals 1. That's the other half of my solution. So now I can put it together as an ordered pair. So my solution is 1, comma 2. Okay? 1, comma 2. Now you guys are going to try 1 on your own. No, you're not. Why do I keep saying that? I'm going to do 3 examples, and you're going to try 2 on your own. Okay? So now here, I'm going to do this again. I'm going to first isolate a variable, which I already have. So I'm going to take what it equals and plug it in for that variable. That's right. Oh, why did I plug it in there? That shouldn't be plugged in there. Hold on. Pause for a second. I'm going to fix this. Please tell me I did this correct. Yeah, I did. Okay? So I'm going to take... Ooh, delete. Okay, I'm going to take what it equals and plug it in for the y. So I have x minus 6. So I'm going to distribute that -1. So I get x minus x plus 6 equals 6. Then I can combine my like terms, and they actually cancel out, and I'm left with 6 equals 6. And I can't solve for any variable because I don't have anything left. So when this happens, what it means is that when you cancel out your variables and you're left with a true statement, just like with normal equations, that actually means infinite solutions. Because of this, you've got a true statement, you get infinite solutions. And you're done. Okay? Let's try example 3. We're going to find the solution to the system by substitution. So again, I need to isolate a variable. Here I have them both. I'm just going to go ahead and take this one and plug it in for the y here. So now I have -4x plus 5 equals -4x minus 9. I'm going to add 4x to both sides, and what I'm left with is 5 equals 9. So again, all my variables are gone, but this time I'm left with a false statement. Okay? When that happens, you have no solution. Okay? And now you guys are going to try 2 on your own. Okay? The last example is using substitution to solve a real-world problem. So when this happens, you need to set up your system of equations, and then once you have it set up, you can solve it by substitution. So Steph in school is going to sell tickets for a choral performance. On the first day of ticket sales, the school sold 3 senior tickets and 1 child tickets for a total of $38. The school took in $52 on the second day by selling 3 senior tickets plus 2 children's tickets. What is the price of the senior tickets and price of the child ticket? So first thing I want to do is figure out what are my variables. Since they're asking for the price of the senior ticket and the price of the child ticket, I'm going to make something. Nope, not that. I have things. I just don't know what happens to them. There we go. I'm going to make S equals senior ticket and C equal child ticket. And you can pick any variable, it doesn't matter, but you definitely want to define your variables because that's going to help you set up your equation. The next thing I'm going to do is look for totals. So I have a total of $38 on the first day, okay, and I have a total of $52 on the second day. So to make my equations, I'm going to look at what made up those totals. For the first day, it was annoying. That's what it is. Really, really annoying. Okay. The first day was $38 total, and it was made up by 3S and, so plus, 1C. So that's my first equation. 3 senior tickets plus 1 child ticket equals $38. The second day, I had a total of $52 from selling 3 senior tickets and 2 children's tickets. So my total my equation would be 3s plus 2c equals 52. And that's my system. That's what I'm going to solve. Okay? Now I'm going to do this by substitution. Now, unfortunately, none of these variables are already set equal to. So I have to pick one to get by itself. And the one I'm going to pick is this 1c because it's only 1c. I don't have to worry about dividing by anything. Okay? So I'm going to get this 1c by itself. And I'm going to subtract 3s from both sides. Okay? That'll leave me with c equals negative 3s plus 38. Now that I have that, I can plug it in for this c right here. So that's what I'm going to do. So I have 3s plus 2 times the c here, the negative 3s plus 38. And that all will equal 52. Now, I only have one variable in here, which is great, just this s. So I can go ahead and solve. So first I'm going to distribute. So I have 3s, oh my gosh, 3s minus 6s plus 76. I'm going to combine my like terms, and that gives me negative 3s, bring everything else down. Now I can solve. I'm going to subtract 76. So now I have negative 3s equals negative 24, divide by negative 3, s equals 8. Okay? So that's the price of the senior ticket, is $8. I'm not done though, because I also want to know the price of the child ticket. So I need to take that s and plug it in to one of my two equations. I think I'm going to plug it into the top one because, again, I don't have to worry about dividing with the c then. So I'm going to plug it in. Where did I plug it in? So I have 3 times s, which is 8, plus 1c equals $38. So I'm going to simplify. 3 times 8 is 24, plus c equals 38. Subtract 24, so I get c equals 14. So the child's ticket is $14. Now, I am not going to write this as an ordered pair, okay? Because this is a real-world problem, I'm just going to answer the question, okay? Which is, senior tickets are $8 and the children tickets are $14. That's my answer, okay? Now you guys are going to try this one on your own. Give it a shot, okay? Even if you don't think it's the correct equations, you can still try to solve the system and practice substitution then, okay? But go ahead and give it a shot. Try it all the way through, okay? Even if you're not 100% sure on the equations, just try it. You might surprise yourself, or at least get some practice. There's not really a negative to trying it, all right? But if you have any questions, I'll be happy to answer them next class. Other than that, I will see you guys later. Bye!